This is Greg Troutwine with Marine Technology TV, and we're here again with Tim Janssen of Sofar Ocean for an update on the technology and the direction of this innovative company and its mission to efficiently, effectively harvest data from the ocean. Tim, I know the most watching know the Sofar Ocean brand. Why don't you just give us an update? A by the numbers look at Sofar Ocean today using the metrics of your choice.
Yeah, I mean, look, really our focus is on spectacularly increasing the amount of data we get from the ocean. So I think those numbers should count. We have over 2,500 sensors deployed worldwide. We're getting over 200,000 daily updates on ocean weather worldwide. We are improving forecasts over, say, the best in the world, say, NOAA, ECNWF, just to call them out, by 40%. So particularly the wave forecast, we validated and published this, by the way, so it's not just me making this up. We can get global RMS error down by 40%, which is pretty big. And then obviously that ties into our Wayfinder application, which now is growing very rapidly across the maritime industry to take that information and translate it into better, more efficient and safer routes for ships on the ocean. So I think that's a fair snapshot. It's it goes all the way from like sensors in the water, data from the ocean, translating that to reducing the uncertainty in the future state of that ocean, into like how does that impact operations for like a shipping company or a captain or a master on a large vessel.
So we talk about finding, delivering, and using the massive amount of information from the ocean regularly. And as you know, there's a lot of different independent organizations and collaborations that are working towards the same goal. What makes Sofar Ocean unique?
Yeah, I'd rather focus on like where we're not unique, in the sense that I think like this is one of the biggest problems we're solving right now as a community. Like the ocean is so far behind in terms of like data acquisition. Like I typically refer to like just like the 11 orders of magnitude difference. As humanity, we collect 1 trillion gigabytes a year of data. We have 11 orders of magnitude, roughly, by my best estimates, difference between that and what we collect in the ocean, which means that if you think about the distance from here to the sun and equate that to the total amount of data we collect every year, we get about 1 to 10 meters on the way. That's all we're gathering in the ocean. That's the difference. And this is a compounding problem. Like every year we're adding that gap to it. So look, we are complementing. Like we are a company that does things at scale. We're hyper focused on collecting as much data as we can, as quickly as we can, and we're complementing other organizations, both government and other industry organizations. And really, I think our role, and I think everybody in this community and most organizations, I think, operate like that, is really to help others succeed as well. Like there is so much need for more information. We can't do everything ourselves. Neither can anybody else. It's really about like holding hands and helping each other and trying to accelerate things forward. So that's sort of like, I think how we operate and how we look at it is like, look, we are building scalable networks of certain observations that are really important for our specific application, around weather on the ocean. We're building an ecosystem of sensing capabilities that are broader than that. But really, I think where we find our strength is around working with other organizations and see how we can help them progress their needs.
As you well know, there is many use cases for information from the ocean and pretty much as diverse as the information and the data itself. But let's take a bit of a deeper dive into weather forecasting, as this is obviously topical with the seeming increasing frequency and ferocity of the storms. Can you discuss how Sofar Ocean's solution is optimized to make weather forecasting more efficient and more effective?
Yeah, I think maybe step one is really, acknowledging that models are only as good as the data you put into it. Obviously, a model is a representation of our physical reality, and it has to be doing that pretty well. But from that point onward, it can only translate what we know about right now, the now state, to a future state by translating that information forward in space and time. So assuming that the model can do that reasonably well, which I think is fair to say most weather models today can do reasonably well, the way to make them better foundationally is put more information into them. And that's why we are hyper focused on creating large networks of sensors rather than one, say, exquisite data point with 20 decimal accuracy. It's not going to do anything for a model to have one data point somewhere in the middle of the ocean. It's a very big place. We want to do something. We got to have a lot of data to constrain an outstate better, make forecasting better. So the principle is very simple. Technically, it's described as data assimilation, which basically means like we're taking all the sensor information we can get our hands on. We have our own network of thousands of sensors worldwide. We ingest that data. We take any satellite data we can get our hands on, data from other networks that are public, and we put all of that information into our models, on the now state. We tell the model like, look, this is what we know about how the weather is behaving right now. Take that, correct whatever you thought was going on, and translate that into like what's happening in the future. So foundationally, our whole system is built around reducing uncertainty by creating massive amounts of data to better constrain the now state and improve forecasts. And this is exactly how it works today. So we run our own operational numerical weather forecast models in the cloud. We gather all this information every 6 hours, get everything together, run a forecast cycle, and basically improve the forecast, that way reducing the uncertainty. So I think from the ground up, the whole system is really designed to be a very effective way of reducing uncertainty in forecasts. And the reason why I think traditionally that hasn't been as easy, for say government organizations, is that observations, modeling, and dissemination of the outcomes are actually separated, quite rigorously. And so what we have is we have everything under one roof. So basically, if our modelers find that like, hey, we need this other piece of information to constrain our models much more effectively, we could have that out in our network 3 months later, say, when we have gone through a hardware cycle. Now that sensor is on there as well, and now immediately drives improvements. That is a level of flexibility I think we've never had before, and it's really sitting on new technologies. Like how cool is it that a small team like ours can actually run numerical weather forecasts in the cloud? I mean, that's cloud computing. It wasn't possible 5 years ago. The fact that we can have IoT capabilities to make sensors that are low cost enough that we can deploy them at scale and actually have real-time connectivity and drive that information to our models. Again, something that we can do today wasn't possible 5 years ago at the scale we're doing it now. So I think it is the combination of like bringing everything together, like hardware, sensors, data assimilation, models, dissemination of information, and just the luck or the timeliness of the fact that basically the technology is there to execute on that effectively.
I mean, is this network, just so I understand, is it at full strength? Is there a plan to add more to that? And again, just to layer one more quickie on top of it, how long is the life expectancy of each of these sensors?
This is basically our network. So as you can see, I mean, these are live sensors. You can click on a buoy somewhere, and here you see basically the yellow line is the observation, the red line is our model, and then this is basically the future state of that model. And so you can see that basically the sensors are worldwide, literally. I mean, we've deployed them in every major ocean basin, collecting information continuously. And that's really, I think, the art to improving the forecast is around how do we do this on a continuous basis. Like if you put some data in a model and you update it once, you'll get some improvement, but then your model forgets about it and goes its own way. But by having the data there long dwell, continuously hammering basically the model on like, no, you're going in the wrong direction. This is what's actually happening out there. You're making it better every step of the way, and that's the way to do it. So the network you just saw is about 900 sensors. These are all basically owned and operated by us, so that's why I can show them on the dashboard. The other sensors are in the hands of users that basically bought the hardware. With them deploying the sensors, they make the data available to us in sort of like an anonymous way, so we can use the data on our forecast, but we generally don't share them on dashboards, etc. And that's basically the rest of the network, mostly on coastal sites. This is mostly open ocean. And jointly, that data is basically driving the improvements in our forecast. And to your other question, growth, it's never enough. I think it's just a reality, and it really is true. I think look, we're so far off from saturation. Like on that map, you see basically these buoys being, the size of 10 times Hawaii. In reality, obviously, these are like really small dots. You wouldn't be able to perceive them on a map like that. But that still means that basically we have quite a bit of separation between the sensors. Now, to be clear, I think where we are today, we get massive improvements. We're not trying to resolve, say, individual waves. We're trying to, resolve weather systems. and having a couple of 100 miles of separation between sensors is totally fine for that.
Question, because I really wanted to take a deeper dive into the wayfinder. As I said, a lot of my business is on the maritime side. We're dealing with ship owners globally regularly, and I know accurate weather forecasting is very important for the safety of the ship, and also for the efficiency and the emissions of the ship. So can you discuss Sofar Ocean's Wayfinder, the voyage optimization platform geared to assist shipping companies? Can you just take a deeper dive? What do the ship owners, what will they get from the Wayfinder platform?
Optimization should actually be the first thing that anybody with sort of like a logistics problem like shipping has do. I mean, it should be the first idea, not the last one. We're kind of late in it. Like, I think a lot of ship owners have already invested quite big into technologies to improve their vessels, like different paints, even different propulsions, adjustments to the hull shape, without actually really knowing what that's going to do for the performance. I mean, there's promises, obviously, and I think the lack of follow through on those promises actually led to a lot of skepticism around how did these investments pay back? And then the same applies to optimization. I think there is skepticism generally about well, how does that work? And I think it's actually quite simple. And we can be easily, I think, led in the wrong direction by sort of focusing too much on outcomes and not enough on process. And that feels a little bit maybe weird, but I think it's generally true. And I think we as humans tend to have that tendency, we tend to focus on outcomes versus building a better process that will lead to those outcomes. And so the way I think about optimization as a problem is look, the optimization problem itself is not that difficult from a purely technical perspective. It's basically you're assigning some sort of cost function to different options. So you have different strategies of going through the ocean, different route, different speed profiles. You assign a cost function, which basically translate whatever you do in terms of dollars. And that could be because of the time spent on the water, because of the fuel you're burning to reduce that time spent on the water. And then you minimize that. It's basically a simple minimization problem. What's really important, and again, we know how to solve that. It's not like I'm not talking about us knowing how to solve it. Everybody sort of knows how to solve that because everybody uses Google Maps and it does exactly the same thing. What's really important is the inputs and the adherence, how well are you following your best strategy. So the inputs in this case, if you're thinking about voyage optimization, for the most part is one, weather, which is your resistance, basically the traffic that you would encounter on the street is basically weather in the ocean. Big waves means you're going to have to spend more fuel or go slower or both to get through it. So the resistance factor is weather and how it interacts with the vessel. That's the second part. Vessel performance. How does this specific vessel actually interface or interact with the weather, which basically will tell you how much performance loss or how much fuel you're going to have to spend to boost your performance to where you need it to be to get through that weather. And then the last part is market variables, the economics of the optimization. Obviously, all this friction resistance is completely futile if you don't know what the cost is. If you want to translate things to how much is it going to cost me and how do I economically optimize for the outcome, you got to know what is the value of the vessel, in terms of what could it be doing otherwise if it wasn't on the ocean, and how much does it cost to reduce the time that it's spending on the ocean, so fuel burn. And then there could be other boundary costs, like for instance, the cost of arriving early or late, et cetera. Those are the three big buckets of inputs. And what we typically tell our partners when they consider adopting an optimization platform is you should really be thinking about that. Make sure that you have the very best weather, reducing the uncertainty of the environment you're going to be operating is a big deal. You need the best possible vessel performance model, which is a combination of both the information you're getting from the vessel, what is your performance level, and the exterior information around what's the environment you're operating in, because that relationship is really what you want to understand. And finally, obviously, real-time updates on how your market variables are changing. All of this is dynamic. None of it is static. And this is, again, traditionally, it was a set and forget type strategy. We come up with a passage plan. It's a lot of work to change that because you got to change documents. So we don't. We just go and hold basically the course, so to say. What we're trying to do is really changing that paradigm altogether. Every 6 hours is an opportunity for change. And this is not weird. Market variables are very volatile. Fuel prices go up and down 50%, day on day. Weather changes every 3 hours. So to set and forget would be a very bad idea if you're thinking about, say, a transoceanic voyage that could be 30 to 40 days. And so every 6 hours, we reevaluate that, run it through our optimization, and basically come up with the next best strategy. Like, what is the best strategy to execute on, given all the information we have right now, knowing that in 6 hours, we're going to revise that again because the information has changed. And then the last step is around like adherence. Like, how well are you tracking this strategy? Because this is a change management problem. Theoretically, this is all technically doable. But you have real people in the loop. There is commercial operators that are managing fleets of vessels that are interacting with the master and crew around like what the best strategy should be and how to execute against that, and making sure that everybody's on board with like, hey, we need to update the information. We need to make sure that we are ready to accept changes in our strategy based on that best information, and then execute against them. Those are, I think, sort of like the way we break down the problem and how we work with partners to engage them on not only like, hey, here's the technology, and you can have that pretty much for free. What the challenge is for you, and this is something that obviously we work with, with partners on. It's not something like we throw it over the fence and then forget about it. Like, how do you implement this? How do you create a workflow and the workflow changes needed to effectively execute against it? That is really, one of the core sort of like messages we bring to like, the technology is not that hard in many ways. Like, getting best data is hard, and we kind of solved that problem. Now, basically, the next challenge is really around like, how do we execute on it?
I'm interested to know, can you put a little size and scope to Wayfinder today? Who's using it? What are the results they're getting? But also, is Wayfinder, what is the deliverable? Is it a product, or is it just the way in which you deliver the information to the ship owners, to the ship managers?
Yeah, great question. It's actually a really good question in many ways. I think the answer is somewhat in flux, because I think we're all, and this is not just us, but I think the industry as well is wrapping their head around this. On the one side, who uses it? It really goes across the board. We work with large container carriers, all the way to dry bulk, liquid bulk, even cruise liners. The economic models are a little different for some of these. Like, for instance, on a cruise liner, revenue is not driven necessarily by carrying cargo alone. And also, like, if the weather is bad, nobody's going to be gambling or enjoying the show. So it's a different model, but it is still about a weather-driven revenue model. Like, it's foundationally not that different from driving a dry bulk carrier across the ocean, if you will. So the same principles apply, and the same sort of like optimization paradigm can be used. I think it is a product. So the product really is focused specifically on the operations in a company, and it can be integrated in other things. When you say like vessel management or fleet management platform, that is a really broad scope. I mean, there's a lot of things in there that we specifically do not do. Like, Wayfinder is hyper focused on delivering the best routes and optimization of both waypoint selection and speed. It is optimized to make sure that everybody's looking at the same information. It is on board and on shore, and basically making sure that there is seamless interaction on the same information, and that adherence of the best strategy is maximized. Now, it can also be integrated in other platforms. Obviously, we have an API version of the product that allows somebody who has a broader ERP, for instance, that has a much broader application across the company, beyond, say, operations, but potentially fleet management or fleet performance, could easily integrate with it. In fact, there is overlaps that we've come to realize that are actually quite meaningful. Like, for instance, as I described, one of the key components of optimization is vessel performance understanding. Like, how is this vessel actually performing, to know what choices to make it as performant as possible for this specific voyage. That performance is modeled by us with extreme accuracy, because a big component of the performance understanding is like, what was the weather? Like, if your vessel is performing X, knowing exactly what the weather was at that time point is actually going to help you make a much better model. So as a result of best weather, we also get a big enhancement in our vessel performance model. And for some companies that we work with, that vessel performance model in itself is actually really valuable, because they can use that in other parts of their organization to help understand like what is the specific performance of these vessels right now, how is it changing over time, should we plan and schedule a dry dock. So there's actually a overlap that way laterally, despite the fact that our products, which is the Wayfinder application, is hyper focused on route optimization, working with commercial operators and crew. And so as a tool, I think it's either used that way, like narrowly, or more broadly through API implementations, or just simply taking the data from our platform and using it in other parts of the organization.
You know, we talked about your network, and the Sofar spotter kind of sits at the center of what you do. But can you discuss recent or planned enhancement to the tech or the network that are designed to enhance the performance or perhaps unlock new use cases?
It's fair to say that in some ways, the spotter is sort of like the core and the foundation of what we do. Like data acquisition, driving unique, data into the system is absolutely essential for us to be, significantly better at what we do than maybe others. The spotter itself, we have actually pretty major plans for it. We're launching something that's called Bristlemouth this year, which is much bigger than spotter. But foundationally, what it allows us and others to do is to add new sensors on the spotter platform. So Bristlemouth, the simplest way to think about it is USB for the sea. So not USB-C, but USB for the sea. So it's basically an open, is community open hardware interface that makes it incredibly easy to connect things together. Not just a sensor to a spotter, but if you want to build, say, an ROV, this is the easiest way to like plug things together because it has a very low cost waterproof connector, something that's very difficult, strangely enough, in the marine space. You want to buy a connector? Good luck. It's very expensive, and you're probably going to have to wait a while. So that was a big pain point for us because we can't handle expensive connectors, and we certainly can't wait a while. So we built basically a connector protocol, which is similar to USB, not just a connector, but it actually has a modern software stack that allows very, very easy integration of components in the marine space, and everything obviously is waterproof. So it's basically if you want to use the analogy to USB, it's a USB that's modified to work really well for marine applications. It's going to be community standard, open to everyone. Anyone can use it. But that's really, I think, one of the main drivers to innovation and unlocking of innovation in the marine space, because that level of scale and the ability to take a sensor and integrate it to something else is completely lacking today. And by unlocking that, what we hope to achieve is to not necessarily for us, but for the community as a whole, for more innovation on sensor development to be unlocked, so that we get more low-cost sensors, more low-cost components that are easily scalable, to not just sort of like from our perspective, like just have more things on our platform, but in general help accelerate ocean exploration and sensing. For us, though, what it will do is it will make it easier for us as well to add new sensors to our spotter platform. So the logical extension for us, and this is something we've been doing for the last couple of years, is just add new sensors. Like think about underwater sound, which can help constrain the surface interface, because we can listen to breaking waves, so we know how fast the wind is blowing and how much turbulence there is in the surface layer. We've added a barometer recently, which makes all of our sensors now measuring surface pressure, which is one of the main components that go into atmospheric modeling. And so unlocking and accelerating the way in which and the pace at which we can integrate new sensors is really one of the main things that we're going to be focusing on this year on the hardware platform.
But with your progress to date and plans for the future, what can the industry expect from you in 2023, which you've partially answered, but I guess, how do you see this company evolving in the coming 5 years?
Yeah, I'll tie it back to our mission. Our mission is to connect the world's oceans to contribute to a more sustainable future. And that's really, really important to us in pretty much everything we do. So there's two main pathways that we are going to focus on for the next few years, and where we sort of like see our future consolidate. One, obviously, we built this platform for maritime shipping that's going to help reduce emissions. It's going to be tying into like new CII regulations, and it's going to help the industry accelerate its journey towards a more carbon-free future, which they're very ambitious about. The whole industry is I think focused on that. And I think we have a platform that can help, and we're accelerating like crazy there, and that's something we will continue. On the other side of things is that ocean sensing in general is still in its infancy. And you can think of like modern problems around carbon flux measurements. Like if we want to think about like if we can capture carbon in the ocean, great, but we need to measure if that's actually effective. And we don't know how to do that at scale today. So Bristlemouth and an open platform for enabling innovation on ocean sensing is the other side of the house, where on the hardware side, we want to accelerate basically community involvement around innovation in the hardware space. And partially that's selfish in the sense like we want those sensors to be available and we want to put them on our platform. But on the other side of that, that would benefit and should benefit everyone. So it's, I think, something that fits squarely with our mission. I think from a company perspective, it's something we should do. We have a lot of partners in this across philanthropy, government organization, and industry to help accelerate that pathway, and which is effectively a community effort. It's not something we can do alone, but it's something I think that we're really excited about. And I think we're going to see a lot of really exciting new steps develop this year and following.
What do you consider to be the greatest challenges ahead to achieving your vision for the company, and how is Sofar Ocean investing today?
Yeah, that's a good question. I think, philosophically, I think I think most every founder and co-founder would agree with me that it's the unknown unknowns. I don't think there's a single challenge that I would say like, well, that's definitely going to be the biggest one. And if I would call one out, I'll be wrong. I think the reality is just that basically you set out a strategy as a team and as a company, and you accept that you adjust it as you learn more about what you're operating in. Everything we do is brand new. Nobody's ever done it before. And I think that's something just to embrace and operate in a manner that sort of like fits that. And obviously, look, our challenges are no different than any other company. Like basically, obviously, there is a change in the economic climate. We're lucky that doesn't really seem to impact our customers that much, and we'll have to, figure out ways of like operating in that new environment, like everybody else. But I think in addition to that, in a company that's focused on innovation and it does nothing but innovation, and bringing technologies to other industries that haven't worked with that technology before, or developing completely new technologies. I think our biggest challenge is basically that we have to, as an organization, be ready to adapt to learnings as we go. Like every month, we'll learn something new that is generally an opportunity, or it could potentially be a hurdle, or both. And basically, our biggest challenge, I think, as an organization is to be and remain very good at solving that. And that's been, I think, as any growing company could probably acknowledge, is that as you grow from a very small team to a bigger team, and we're still a small team, but much bigger than, say, a couple of years ago, maintaining that ability to be both sort of like capable and flexible at the same time is a challenge. And I think we're pretty good at it, but it's definitely something that I think we should keep an eye on and make sure that we retain that.
Okay, so Tim, I truly appreciate your time. It's actually been fascinating to catch up on what's been going on in the last year and a half or so, and I look forward to talking to you and your team again in the future.
Thank you, Greg. Pleasure to be here.